And then I hooked up a level shifter so I can use those because they're going to run at a different voltage than the Arduino stuff is. So then I can actually interact with a console port over XB with my Arduino. So if I could get this into some company or something like that, then basically I have remote access to their console. Or I could use it, I guess I could use it legitimately as well. If I want to put a router somewhere I didn't want to go touch it actually, then I could do that. But so here's a picture of the top of it. So basically the wires come up and then I just put my Arduino and stuff on top. So another thing you can do is you integrate it with a cell phone. So like I said, you can buy a cell phone shield, but that didn't seem as much fun as trying to do something with a cell phone itself. So what I ended up doing is I pulled off the keypad of this cheap prepaid cell phone that I had. Yeah, the keypad stopped working anyway from the top, and so I just ripped the keypad off, the rubber stuff, and then I just connected transistors to each of the button things on the cell phone. So basically I had a big ring on the outside and then a little circle in the middle, so I just put a transistor between the two. When I put power to the base of that transistor, it essentially makes that connection, and so it pushes the buttons. And I could connect these all directly to my Arduino, but then that would use up all my pins. I couldn't do anything else with it. So use what's called a shift register, which lets you shift out what you want it to do. So you can do the high and low signals using these shift registers. It only uses like 4 or 5 pins. But I ended up using the centipede shield, which like I said, that's I2C. So it just uses 2 pins, which like I said, it's a bus protocol, so I can use a lot of different I2C devices. So essentially it doesn't use any pins to be able to do that. So I communicate to remote devices, interact with touchtone systems. Anything that I want to use a cell phone for, I basically can hit any key and do whatever I want. So here's the schematic. Like I said, it's just this transistor, the resistor to the base, and then going to some Arduino pin, and then the two pieces of the cell phone button. So I have a video of this.
Did you get that through an airport?
I did not try. I don't know what they'd say. I can't see what's up. Okay. Am I hitting the play button? It's not playing though, huh? It's thinking. Fantastic. I wonder if it wants me to. Okay, well, guess we're not showing that. So basically, all you see in the video is you just see the cell phone, and you'd be able to see I can push any button that I want on the cell phone, and it just reacts like you would if you push buttons on a cell phone. And you can use the same technique for anything that has buttons that you want to automate something that it does. So you could do this with like a game controller. Here's a close-up picture of the cell phone. So like you said, it may be hard to get this through airport security, just this phone with all these wires coming off every button. But yeah, so anyway, so you can use this for anything where you have pretty much anything, any electrical device will open it up. You'll either have these jaggy things, and so when you push the button, it just grounds it just connects the two, bridges the two, or it has something like this where it has this outer circle and inner circle. You just solder to them, you put a transistor on them or something like that, and you can run the device. Another thing that I made that I'm kind of working on still is this combination lock brute forcer. So basically what this is a stepper motor that turns a dial, and a servo that tries to pull the shaft out after it tries 3 numbers or whatever. I have a laser pointing to a photoresistor that detects 0. So I use that for a couple of reasons. So one is when it's to make sure it's not getting off. And the other thing is a lot of locks have known algorithms like the master locks where you pull the shaft out, you turn it until it stops, and then you just write down all those, and then you let it go back in, then you pull it back out again, turn it more until it stops. You write down those numbers, and you can reduce the number of possible combinations down from 16,000 or something like that to about 100. And so this can do things like that because it goes till it stops. Because with a stepper, it all it knows is I'm trying to turn it, but if you stop it from turning, it doesn't know that it wasn't able to turn. It doesn't have any feedback. And so I just turn as far as I can, then further than I think I'm going to be able to turn it, and then I just come back and see where it hits 0, and I know how far I went. And it can use known algorithms. Like I said, I already said that. So, and it can also try every possible combination. So here's a picture of it. I actually realized that I forgot this when I got here, so I started rebuilding it, but I didn't get it done. So, sorry. But, so here's a picture of it though. So basically, the servo on top, and the metal plate is just a cover plate, electrical cover plate I picked up at Lowe's, and it just has those bolts so I can adjust the height of it, make sure it's the right height for my lock. And then this plastic stuff, it's called shape lock, that I use. So you can see there's a servo at the bottom that tries to pull the shaft out. There's the button that detects if it is pulled out. So it's pretty easy to make, really. You can just pull a stepper out of an old printer if you have, or just buy them online. They're about $15. You probably need like a stepper driver to be able to drive it easily, like an easy driver or something like that. So one thing I want to say though about that plastic stuff is it's called shape lock, and it's rad. It's really cool. So basically, see these little plastic beads. You get water, you heat it up in the microwave or something like that, and then you can make it into any shape you want until it cools down, and it's really pliable and things like that. As soon as it cools down, it gets really hard. You can drill it, you can cut it, you can do whatever you want. It's really cool stuff if you have to make custom pieces. And for this, I need to have a piece that fit over the lock and fit inside the stepper, or over the stepper shaft and over the lock dial. And so I didn't know where to get anything like that, so I just made it with this stuff, and it worked really well. Yeah, you can. So you put it back in the microwave in the water or whatever, and it just remelts. You can reuse it. It's cool. And so that's one thing though as well. So you don't want to use it for something where it's going to get hot. So like anything outside here in Vegas, you probably wouldn't want to use it. But so I think it melts at 150 degrees Fahrenheit, and then yeah. So as long as you keep it below that for whatever you're doing, they should be good. So another thing that I made using the shape lock stuff was a key impressioner. So basically this works only on wafer locks. This won't work on a pin tumbler lock, just wafer tumbler. So basically what it is this piece of, this is actually shape lock as well. So I took this piece of shape lock, flattened it way out, made it about the same shape as the key. And then I have, so there's several exposed wires at the very end of it, the very tip of it. And then there's wires connected to the body. There's a wire connected to the body of the lock. So I'll kind of show how this works a little bit. So here's a pin tumbler lock that you guys are probably familiar with. So it has all these pins. They're cut at different lengths. But when there's no key in it, they're all the way down because you have those springs on top. You put a key in, if the key is the right shape, then it's going to raise them all up at the right level. The cuts in the pins are going to be at the right place, and you're going to be able to turn it. A wafer lock works a little bit differently. So a wafer lock has all these wafers, and they're if you look at the one on the left, then they're all, without the key in it, then they're all different levels, right? So this is actually the level that you need to be able to open it with a key, because you want them to basically all go straight up at the same level they are, so then it's not locking it. And so then that's what the key does. And so what that means is if I can get a device in there and I figure out what level they're at when they're down, then I know what the key looks like. And so basically that's the way this key impressioner works. So like I said, I stick this piece of plastic in at the red is the wires. At the very end, towards the tip, that angle tip, they're all exposed. And so then the blue things are the tumblers, if you can tell. So what I do is I put the key impressioner in. As you pull it out at the right places, you have to figure out where the right places are for that right lock. Then it will just hit that one wire, that one exposed wire, and so you'll know, okay, this one goes down 3/4 of the way or something like that. So then you know what that key looks like as you pull it out. And they're coming out with some like professional versions of this. I think this year you're going to see some coming out. So, but it's kind of an interesting little project that I've just been messing around with just the last week or two. And so, like I said, then all you do is you connect like power to the outside of the lock, so just the body of the lock, and then you connect all these wires coming off the back of this to your Arduino, and then you just see which one's given a high signal coming in a digital read, because that's the one that's going to actually be hitting, because you have the body giving power, and then and so it's going to go through the body of the lock, through the outside, through the tumblers, and into the device. So another really cool thing that you can do is you can combine devices. So you like it. We've talked a little about this before. So you take an XB, and you take an Ethernet, and you put those together. You can take an RFID reader, and you broadcast using cell phone or using XB or whatever you want. So you can have this remote RFID reader that's reading stuff. You can use Bluetooth for motor control. Using your Arduino or something like that, so you have some robot, you can control it using Bluetooth. So it's just really cool the things you can make when you start combining things. So some other interesting Arduino libraries that other people have come up with, there's actually a cryptography library, so you can do cryptography here. It's really slow. There's another project where people are unlocking doors by knocking a certain signal on the door, then the door unlocks. There's a university that's doing a project where you come up to somebody, you do a special handshake, and you're wearing a special glove connected to an Arduino, and it will make sure you do the right handshake to make sure that you're who you say you are. You can also make an Arduino-based oscilloscope. It's kind of like a poor man's oscilloscope using the analog read pins. It's not super fast or the best thing ever, but it works, and gets you buying a lot of projects. So like I said, Arduinos are really cool, and I love Arduinos, but there's also some other alternatives that, depending on what project you're doing, you may want to look at. The Parallax Propeller, they're selling the kits here in the Hardware Hacking Village. It has 8 cogs, so it can do 8 things at the same time, which is pretty cool. It can do video and audio and things like that, so you can output to a TV. AVR, just basically, this is the chip that's on the Arduino. You just take the bare chip and use it. And like these are probably between $2 and $4 a piece, and so they're a lot cheaper than using an Arduino. You can also use a PIC, so they're pretty cheap to buy. The thing with PICs are, a lot of times you're going to have to buy like a proprietary development environment or something like that, so you can code in C. The assembly ones are free, and you can also do some like limited size of C for free with a lot of them as well, with a lot of the IDEs so. There's also the Freescale one that we have on our badges. I really like this one as well. They're really cool. Using Processing Expert, you can do a lot of cool stuff with them. So here's some resources that you might want to check out if you're looking for some additional stuff. So the official Arduino website is arduino.cc. It has really good forums. The Instructables.com has a lot of cool Arduino projects. I have a couple up there. Spark Fun is a cool place to buy things. Adafruit, Lady Ada, she sells a lot of cool Arduino kits. Maker Shed, Evil Mad Scientist, Seed Studios out of China, and they sell stuff that's really cheap. And these guys, Pololu, they're actually here local in Vegas. I need so I could try to get the brute force for the combination locks working. I needed a stepper driver. And even though they mostly just ship out of here, they let me come in and pick up a part, and they were really cool. And it's Google Arduinos, and you'll find all sorts of websites with all sorts of cool projects on them. So where can you go and learn more? So I go to my local hackerspace. They do a ton of Arduino stuff at mine, and I know a lot of other ones do as well. So just Google and see if you have one near you. If there isn't one, consider starting one, and just having start spreading the knowledge and things like that. There's also a lot of places like we have a local make group that does the same kind of stuff as our hackerspace. And then the other thing is upstairs there's a Hardware Hacking Village. If you guys haven't made it up there, then I encourage you to go check it out. One thing, just a piece of advice: don't go check it out in between talks, because there's a lot of people just kind of wandering around. It's super packed. Go check it out during a talk. That if there's an hour you don't want to see a talk, then just go and check it out. And there's a lot of people doing cool stuff. People are really happy to help you out and let you borrow tools and just talk to you about stuff. I was talking to a guy yesterday or a couple days ago, about stuff he was doing with Arduinos, and he's been making things for like radio stations and on all sorts of really cool stuff. So then I'm going to put all my code and slides and things like that up on on this GitHub site, so github.com/sketch, where the E is